Hey folks! Some of you are going to need this review and some of you will not. It is a review of graphing linear relations. So remember, relations from yesterday is simply relating quantities together. So in the case of a linear relation, we have x's and we have y's. There are a few forms. There's the slope-intercept form and there's also the standard form that you could be given. And the final example is going to be, here's an equation. Please give me the, oh sorry, here's a line, here's a graph of a line, give me the equation. So we'll go through all of those things. So from grade 10, so the slope-intercept form is y equals mx plus b, where m is the slope. Now I'm just going to go off to the side here. Slope can be represented in a few ways. It can equal rise over run. Slope can also equal, if we're just given the x and 2 points on the line, you can say the rise, which is y2 minus y1 over x2 minus x1. So there are two different ways that you can calculate slope. And b is going to be our y-intercept. Now for me, graphing from slope-intercept form is the easiest. The absolute easiest. Now I just need to get a little bit of a thinner, yeah, there we go. So here's the example here. We have a slope of -5 over 2, and we have a b, so this is our m, and here is our b. So the way that I would start is I would simply draw my points. So I know that my y-intercept is 1, so my y-intercept goes here. Y-intercepts are always on the y-axis. That's when x equals 0. And what I'm going to do is the rise, it's -5 over 2. Or you can say 5 over -2. It's good to be flexible with both. So we're going to go down 5. 1, 2, 3, 4, 5. And over 2. So in this way, I went in the positive direction when we went to the run part, and I went in a negative direction for the rise part. Now I'm going to do the opposite here. I'm going to go up 5, 1, 2, 3, 4, 5, and over 2, 1, 2, in the negative direction. So when I have these three lines, or these three dots, really you just need 2, but having 3 is always gives you a more accurate graph. Just connect them. Whoop. And there you go. Now here's the cool thing. You can always pick a point on this line and plug it into the equation, and whether it be your x or your y value, and you can solve it for your x value or your y value, whatever you want. So say I put in x equals 1 into this equation here. So what is my y value? Well, y equals -5 over 2 times 1 plus 1. Y equals -5 over 2 plus 1. But I want to get this as a fraction, so I say plus 2 over 2 because I want a common denominator. Y equals -5 plus 2 is going to be -3 over 2. So the point 1, -3 over 2 should be on this line. Now this isn't perfect, it's totally approximate, but if I would go to 1 and I would go here, well, yeah, it should be 1.5, but I mean I'm just freehanding it here. So I would say that that's a pretty good approximation. When you graph things, you do not have to do this. I just wanted to remind you that equations are cool and we can substitute into them. I'm hilarious. Okay, so standard form, just like the quadratics, has kind of like an ax plus b, by equals c. Or we can say ax plus by plus c equals 0, where where a and b cannot equal 0. They can't equal 0 together. Okay, so a can be 0, because then that will just give us our horizontal line, y equals something. Or b can be 0, because then we would have a vertical line, just x equals something. But you can't have both a and b equals to 0. So when we get this, we want to use x and y intercepts. So the x-intercept sub y equals 0. So 4 times 0 minus 3x equals 8. Negative 3, x equals 8. X equals negative 8 over 3. Okay, so that is going to be, just for us, x equals negative 2 and 2/3. So the x-intercept is always going to be on our on our x-axis here. So we're saying that our x-intercept is at negative 2 and 2/3. So we're going to go right here. And if we wanted to find our y-intercept, just want to go like this so we can still see it. Y-intercept, we use, or sub, x equals 0. So 4y minus 3 times 0 equals 8. 4y equals 8. Y equals 2. So this is where my y-intercept occurs, at y equals 2. So right here. So I have 2 points. Connecting 2 points makes a line. Woohoo! Just like that. So that's how I would graph it from standard form. Now you can always isolate y for slope intercept form. So the way that we would do that is I would just say 4y minus 3x equals 8. I would isolate the y, so I would say 4y equals 3x plus 8. Divide everything by 4. So y equals 3 over 4x plus 8. 3 over 4x plus 2. So we know that our y-intercept is going to be 2. Ding, 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 which it is. And we have a slope of 3/4. So if I would go down 1, 2, 3, and over 4, this is where it would hit, which makes sense because it doesn't quite get to the 3. It still needs a little bit longer to go. So these two things are the exact same line. For me, using the x and y intercepts makes a whole ton more sense. But this right here always can be an alternate option if you like slope-intercept form that much. Okay, so what about writing an equation from a graph? So if you know the y-intercept, it's always easiest to write the slope-intercept form of a line. So for example, write the equation from the line in the graph below in slope-intercept form. What makes me really happy here is I don't have to add little arrowheads on either side. They know what Manitoba needs. So y equals mx plus b, where b is the y-intercept. And m is the slope. So I'm just going to pick 2 points here that are right on the line, here and here. So my slope equals, from here to here I go up 1, 2, 3, 4, and run is 2. So 4 over 2, or that simplifies to 2. So m equals 2. Know that my y-intercept is happening at -3. So I can put it all together. Y equals 2x minus 3. Boom. That is my final answer. Because the slope is 2, up 2 over 1, up 2 over 1, up 2 over 1, and my y-intercept is -3. Some of you folks are going to find this really easy, and you will not have to do a whole ton of practice, even though I've given you a whole ton of practice. Some will find it a little bit more difficult to remember from grade 10. So choose your own adventure, folks. I'm going to make 2 versions of that master check at least. So try a few, make sure that you can do them, and come and grab a master check.